Leetcode question 211 Design add and search words data structure. Design data structure that supports adding new words and finding if a string matches any previously added string. Then implement word dictionary class. Initialize the object. Add words to the data structure so that it can be matched later. And then search words. Return true if there's any string in the data structure that matches word or false otherwise. Word may contain dots, where the dots can be matched with any letter. So from this problem statement, it seems like, okay, we need a trie data structure, but it's different from the standard trie implementation because here we have a dot. The dot can be matched with any letter. Let's take a look at the example. So we initialize the word dictionary and then add 3 words that map into this word dictionary. And then we search for pad, the return value is false. We search for bad, the return value is true because we previously insert bad into the word dictionary. And then we search for .ad, it will match BAD because this dot can match with any character. So the return value is true. And then we search for B dot dot. So any word starts with letter B and then followed by 2 letters. So in that case, we have BAD. So there's a match, the return value is true. So the idea for solving this problem is trie with backtracking. So why trie? We can see that, okay, we add new words to the word dictionary and then trying to search for the words. So that sounds like a standard trie implementation. And then backtracking is for handling this wildcard character dot. So basically, the idea is, let's say, we need to consider every possible option for this dot. So in that case, okay, we need to consider every possible options for this dot. Okay, so if any of the option returns true, okay, then we can backtrack. The entire function just return true. So in that case, this search function returns true. Okay, after considering all the possible options, after checking all possible options, none of them. So in that case, the search just returns false. So that's kind of our idea for solving this problem. So let's first code the trie node. So trie is a tree data structure. So in that case, we need to have a child node. So this children is a dictionary. So in this dictionary, the key is any letter. So for example, it could be the letter A. And then the value is the corresponding trie node. And then for each trie node, we also need to keep track of whether or not this trie node is the end of a complete word. So we use a boolean variable. We initialize to false. So why we need that? Because let's say in this given example, if we search for the input string BA instead of BAD, we just call the search function with the input BA. We can match every character in this BA, but then when this BA adds as the character A, that node is not the end of a complete word. So in that case, we know that we need to return false. If we do not have this boolean variable to indicate whether or not the current node, this trie node, is the end of complete word, then we wouldn't know. We still can match all the characters in this input string, but we wouldn't be able to tell, okay, if this input string ends at a complete word that's already been inserted into the word dictionary before. We cannot tell if it's just a prefix or it's the whole complete word. So that's why we need this boolean variable. And then let's first implement the standard trie in this word dictionary. After that, we are going to modify on top of that to handle the wildcard dot. So in this case, we initialize it, the root. So the root is just an empty trie node. And then we insert word into this word dictionary. So basically, we need to know the current node. So initially, the current node points to the root node. And then we insert character by character in this input word. So if this character not inserted before, then we initialize it and add to the dictionary. And then we move on to the next node. So in the end, after we insert all the characters in this word into the trie, we indicate and mark current.isEnd equals true. In this way, we know that, okay, this node corresponds to the end of a complete word. So that's our add word function. That's the standard trie implementation. And then let's implement the standard search in the trie. So we still points to the root node at the very beginning. That's our current node. And then for C in this word, we're just trying to search character by character. If C not in current.children, so in that case, we just return false. Otherwise, we move on to the next node. And then in the end, after check all the characters in this input word, we just return current.isEnd. So if this node corresponds to the end of a complete word, the return value will be true. Otherwise, it will be false. So this is the standard trie search implementation. So now we need to incorporate this wildcard dot. So in that case, that's a special case. Let's say for each character in this word, if this character is not dot, in that case, we need to check, okay, if this character match with the current child of the node. If it match, then we move on to the next node. So else, if this current character is a dot, so in that case, as we described before, we need to check every possible options. So basically, we need to check every child. So in this case, for the next node, in current.children.values, and now we need a recursive function. We call it function. And then the recursive function should take next node as input, because we know that's the next node to check. Then how do we know what is the next character to check? So because we already checked this character C, we need to move on to the next character. So in that case, let's switch to index representation. So basically for I in the length of this word, in the range of the length of this word. And then we replace all C with word I. And then in that case, we know the next character to check is just I plus 1. So that's our recursive function. We call our recursive function. And we also know that, okay, if one of the recursive function, if one of the option return true, then the search will return true. So we do not need to find all the match. We just need to find one that matches. Else, if we check for all the possible options, and then none of them return true, so in this case, the search function would just return false. So this happens after we check all the possible options. Okay, so we modify the middle part. And then we need to also wrap this one inside the recursive function. So we define the function with input I, and then the current node. So in this case, let's use a different letter j. So different variable name j. So because this I needs to start from the current character at index j. And then we need to update this current. So this current initially points to the node, the input node of this function. And then we also need to wrap this return current.isEnd in this function. So basically that is, okay, if we check, let's say, for all the possible all the characters in this given input word, and then in the end, let's say if we match character by character, and we need to check, okay, if this corresponds to, if the ending nodes corresponds to the end of a complete word. And then we need to just call this recursive function. So it starts at index 0, and then start as the node, root node. So this is our solution. Okay, so this solution is accepted. So let's go back and review this solution. So basically the idea for solving this problem is using Trie with backtracking. So all the part AdWords and search, just a standard Trie implementation. But for search, there's a special case for the input containing dots. And then the dots can be matched with any character. So in that case, we use the backtracking to handle this wildcard character dot. So basically the whole idea for this backtracking is we need to consider every possible options for this dot. Basically, it can match with any child of the current node. And then if any of the options return true, basically we find one match that's sufficient, then the search function returns true. Otherwise, we check for all the possible options and none of them return true, then this search function will return false. That's the key idea behind this backtracking. And then we start with initialize the trie node. And then for this word dictionary, the add word is the standard implementation of the insert into the trie. So in that case, we just insert character by character. At the end of the words, we just mark current node dot its end equals true. We assign the true value to current node dot its end. So in that case, we know, okay, so this node corresponds to the end of a complete word. And then for the search function, we use a recursive function. So this recursive function takes input j. J indicates the index of the current character in this word that we are trying to match, and then also the current node. So initially, we just assign this node to a variable called current, and then we consider starting from this character at index j up until to the end of this word, basically for every character starting at this index j, and then add as the end of this word. We just consider two scenarios. The first scenario is the pretty standard scenario, no wildcard dot. So in that case, we just check, okay, if we can find a match with this character. If we cannot find a match, we return false. And then if we can find a match, we move on to the next node. That is the corresponding child node of the current node. And then we find the next trie node by matching this key. The key is just corresponding to the key is just this character we are searching for. Else, the second scenario is this character is just a wildcard dot. So in that case, we need to consider every possible child of the current node. So that's our next node. And then we also need to move on to consider the next character in this input word. That's why we call function with the input i+1 and then also the next node. So the next node is just current node's children. And then if any of the options return true, we just return true. If we search for all the possible options and none of them return true, in the end we just return false. And then outside this for loop, we just return current dot is end. That means we complete the search and then we reach the end of this word, and then we check if the corresponding node, if the current node is the end of a complete word. And then in the search function, we just call this recursive function. We start at index 0, and then the current node is just the root node.